Okay, looking at the triangle containing side 12, I'm looking at this and I'm going, gee, this hypotenuse is 8 square root of 3. What would happen? I wonder if this is a 30, 60, 90. So if the hypotenuse were equal to 8 square root of 3, that means f would be half that, so that would be 4 square root of 3. Would that fit? So let's see, if 4 square root of 3 is the short side, that means the long side would be 4 square root of 3 times the square root of 3. So long side would be 4 square root of 3 times the square root of 3. Well, the square root of 3 times the square root of 3 is 4 square root of 3 squared. And the square root cancel out, leaving you with 4 times 3, which is 12. Oh, it is. Look at that. That's 12. Therefore, I'm guessing that f is 4 times the square root of 3. Now, if you did this using the Pythagorean theorem, you would go 12 squared plus f squared is equal to 8 square root of 3 squared. Well, that's 144 plus f squared. And this is 8 squared square root of 3 squared. Okay, so I have 144 plus f squared is equal to 64. And the square root and the 3 cancel out. The square root and the squared cancel out, leaving you with just 3. So I get 144 plus f squared is equal to, let's see, 3 times 60 is 180. 3 times 4 is 12. 192. If I subtract 144 from both sides of the equation, I get f squared. Let's see, 12 minus 4 is 8. 8 minus 4 is 4. So f squared equals 48. So that means f is equal to the square root of 48. So the question is, does 4 square root of 3 and square root of 48, are they the same? Are they the same? So if I take and multiply 4 times the square root of 3, 4 times the square root of 3, I get 6.9282. So this is approximately 6.9282. Then if I go to the square root of 48, I get exactly the same thing, 6.9282. That's the approximation, which tells me that this 4 square root of 3 and the square root of 48 are the same. Either one of those would be a correct answer for f. Okay, going to G now. G squared plus 2 squared, G squared plus 2 squared equals 10 squared. So I have G squared plus 4 is equal to 100. Therefore, if I subtract 4 from both sides of the equation, I wind up getting G squared is equal to 96. So the way to undo a square root it. What you do to one side of the equation, you do to the other. So G is equal to the square root of 96. And we're done with that. H, 5, 7, H, doesn't look like that. 30, 60, 90 doesn't look 3, 4, 5-ish. It could very well be just another Pythagorean theorem. So let's see, for H then, I'm going to go H squared. H squared. No, that's wrong, because the two legs are 7 and 5. So we would go 5 squared plus 7 squared. 5 squared plus 7 squared equals h squared. 25 plus 49 is equal to h squared. 74 is equal to h squared. So the way to get rid of a square is square root it. What you do to one side of the equation, you do to the other. This turns to h equals the square root of 74. Done. Okay. Matter of fact, let's make this a little neater. We'll take and slide that right over here. Take and slide this right up here. There we go. Now there's G, H, I. Oh, this looks like a 3, 4, 5. If I go, if this is 3 times 4, this is 4 times 4, so I betcha this is going to be 5 times 4, which would be 20. So I equals 20, and this would be because of the 3, 4, 5 triangle ratio. All right. And finally, we're left with J. Okay, and J, this is the hypotenuse is 10 square root of 2, and one of the legs is 10. This tells me this is a 45, 45, 45. So I betcha, I know J is going to be 10 because of the 45, 45.